Okay, students, we're going to do this video for lesson 3.4, truth tables for conditional and biconditional. I do apologize it taking so late to get this out, but here we go. We want to take a minute to make sure that we get these items here. First of all, I guess I could put my little, here we go. Number one, we want to understand the logic behind the definition of the conditional. We want to understand the truth tables for the conditional. We want to make sure that we understand how the biconditional is defined, which we already know that, and then the truth table for a biconditional. And then we'll do an example or two of determining the truth value for a compound statement. And in particular, a particular case, again, we did that before. Also, I'm going to do a couple homework problems and see how that works out on this video. All right. So as we get started, let me get my pen out here. Let me pick a nice color. Okay. All right. So we could think of the question: if A, then P. If I attempt the extra credit, so A is if I attempt the extra credit, like in this chapter, okay, and then P would be I get extra credit points. Okay, if you attempt it, you get some points. Now let's say I told you that if you do an extra credit assignment, you will get some points. Now, what we want to try to do is we want to try to think of the possibilities. Here we have two. We have A and we have a P. Now, because there's two, we know it's going to be true, true, false, false. And we're going to toggle this. Okay, now what we want to try to do, we want to try to see if this can happen. So we're trying to find the truth values for a conditional. Now, what does this bottom mean? The bottom means that I did not attempt the extra credit work and I did not get points. Okay, that can happen, so that's true. Now, how about the second one? I do not attempt the extra credit, but I do get points. Now, can I get points in this class by doing a good job on my assignments? Well, yes, I can. So that's true. All right. Now, obviously, on this first one, if I said I attempt the extra credit and I get points, we're all happy with that. That makes a lot of sense. Now, let's look at this. If I said if A, then P, and you do A, but P does not happen, there's a problem with that. If I say to you, you attempt the extra credit and you do not get your points, you're going to say, I lied. I did not do right. I did not say what I promised. I broke a promise. So that possibility for a conditional is false. Every other one is true. So again, in a conditional statement, we're trying to figure out the truth table. If I have true and false, that's false, but it's true everywhere else. Now, if I have a conditional, and all of my final values are true, and you'll see that at some point in the future, not only is it a tautology, okay, but it's known as an implication. An implication is when you have a condition and all of the possibilities are true. Sometimes you hear somebody say in our culture, you just implied yourself in that particular incident, or the more you talk, it seems like you're implying something. Everything that you're saying, again, that's an implication. That's a loose definition of it, but that kind of helps you think about it. Now, what we need to do is we need to do the truth table for the biconditional. Now, remember, what is the biconditional? P only if Q. And remember what that means. That means if P then Q, and it means if Q then P. And notice I used the word and, okay? So this is really what we want to check out. Again, let me see if I could save myself a little time here. Oh, that worked out good. Okay, so here's my little chart. I'm going to continue it here. Okay. Of course, I like to put a line down here. Now, we're going to have to start by saying if P, then Q. Now, let's perform a truth value, a conditional truth table situation to this compound statement right here. Well, remember, it's only false if I break a promise. That's where the antecedent is true and the consequent is false. All right, so anyway, it's true everywhere else. Okay, so I got this part. Now I'm going to go to this part. If Q, then P. If Q, then P. Well, again, it's true it's true everywhere except where I break a promise. So notice I have a true here, right? I have a true here and I have a false here. So it would be false right here. But it's true everywhere else. Now, my question to you is, can I draw this without making a mistake? That's my question. How about if P then Q and if Q then P? Good question. Now remember it's an and, so it's only true when both of them are true. In this particular row, they're both true, so it's true here, it's false here, it's false here, and true here. So this is a truth table for a biconditional. And I know it doesn't make a whole lot of sense right now, but hopefully in the future you'll see, not too long future, you'll see why we're doing this. Remember, when both of the values for your statements are both true, it's true. When they're both false, it's true. So the shortcut for a biconditional is whenever the values are the same, then you're going to end up with a true statement here. Again, the biconditional. Now, your author gives an example of somebody getting a notice in the mail and looking like they won $1 million. And if you read that part in the lesson, basically what it is, it's a tricky statement, and it's just getting you to sign up for the magazine. But they didn't necessarily win $1 million. And we would call that misleading advertisement. So just kind of keep that in mind. Anyway, I want to talk for a moment about the truth table for the contrapositive. The truth table for the contrapositive. And this is very, very interesting. If you take a statement, if P then Q, and then you do the contrapositive, which is not Q, implies not P, how does that work out? Well, if you notice with the conditional, this was the only occasion where the statement was false. And if you notice over here on the answers, this is the only location, the only possibility where the value of the compound statement is false. Notice that is the same thing. These two statements, the statement here and statement here, are exactly the same. And there's power in that because you could use that. You could use that in a variety of ways. We call that equivalent statements. Okay. Now, here's an example where somebody's making a truth table for this long convoluted statement right here. Okay, now remember, this is the antecedent part, and then there's the consequent right there. And notice it really is a conditional. But if you'll notice over here with all the answers, they're all true. Okay? Whenever you have a conditional that's all true, we call that an implication. Again, an implication. Okay, it's saying something, you're implying something. All right, now here's a silly question. If you're cool, you won't wear clothing with your school name on it. If P, then Q. If you're cool, you won't wear clothing with your school name on it. All right? Now, if I turn that around and said, if you wear clothing with your school name on it, you're not cool. Now, notice that I guess I could call this not Q, right, for not wearing clothing with your school name on it. Now let's turn them around. Let's do the contrapositive. Okay, we're going to turn them around. But remember, we have to negate this, and then we have to negate that. Now, what's the same as not Q? That's just Q, and then not P. If you wear clothing with your school name on it, then you are what? Not cool. Those are actually equivalent statements. Okay? So just kind of run that through your mind and think about that a little bit, see if that makes sense to you. It should. This is a little review. Remember, we talked about negation, talked about conjunction. Remember, a conjunction is only true when both of them are true. We talked about a disjunction. It's only false when both of them are false. Then we talked about the conditional in this lesson where the statement's only false when I have true false, or what I call you break a promise. You're breaking a promise. Okay? That makes sense. And then, of course, the biconditional is true when the truth values are the same, either both true or false. All right? Now, let's see. What I'm going to do is I'm going to do a couple problems from the book. 4 problems, and hopefully it won't make this video too long. I'm reaching for my book right here, and I'm looking at problem number 1. Construct a truth table for the given statement. And here's the statement, P. Okay, let's see if I could put this guy in here and make it work for me. Okay. Let's see. Let's get my pen going again. Where's my pen? All right, so we're going to need a what? We're going to need a better way to write. That's what we're going to need. Let's put a not Q here. Not Q. That's what? False, true. False, true. Okay, I got that. And then we're going to need the if P, then not Q. Okay, so this is assignment problem number 1, and we want to put our values in here. Well, I'm breaking a promise. Where is P true? P is true in these 2 cases. but we want to know where not Q is false. It's only false here. I'm breaking a promise here, so that's false, and this is true. Okay, so that's how you do problem number 1. Another problem I'd like to do with you guys is number 3. Number 3. Not Q if Q then P. Again, we're going to save ourselves a little time here. And we're going to get our pen out. I don't know why I can't keep that out there, but okay, well, we're going to have Q if Q then P. Remember, I'm breaking a promise. So that would be right here. It's true here and false here. And we're trying to find the value here. Well, it's just a negation of the previous concept, the negation of the previous problem. So false, true, no, wait a minute. False, false, true, and false. False, false, true, false. All right, that's problem 3. That was not too, I could have done better. Let's look at 33. 33 says, use the truth table to determine whether each statement is a tautology, a self-contradiction, or neither. Let's see. Here's my statement. Okay, I know these truth statements may seem quite tedious here, and actually they are. Well, I know of no shortcut. Okay, it's hard for me to work on this pad. Remember, breaking a promise. Let's see, we're going to do this, we're going to do this, and Q. It's just a conjunction, so where the last 2 columns true, they're both true here, but false everywhere else. All right, now here's my last statement. You know what I'm going to do? I'm going to try to be fancy here. Put that in there. Okay, so where is the first part true and the second part false? Well, P is false here and here. And the first part is only true here. So that would be, this would be true, true. That's going to be true. This is going to be false, true, which is true. This is going to be false, false, which is true. And that's false, false, which is true. So the question is it a tautology? Is it a contradiction? Is it an implication? Contradiction is false all of the time. Well, it's conditional and it's true all of the time. The answer would be, it would be an implication. That was a mouthful right there. All right, 65. Question says, determine the truth value for each statement when P is false and Q is true. All right, so here you go. It's a lot easier. Okay, so let's run this by. P is false. Q is true. Okay, now remember this is a conditional. That would be true, but it's not true, which is what? False. It's kind of like algebra, but you are training your mind, and hopefully it will come together for you before too long. All right, so that's all about 3-4. I hope this helps you.